How's everybody doing out there? Well, hopefully everybody did a good job calculating our percentiles in our 5 number summary. And so what we want to do is use our 5 number summaries that we found in the last section. And what we're going to do is make a graphical representation of this 5 number summary. And this graphical representation is actually what's called a box plot. So again, if you look down below, this is kind of like what our box plot is going to look like. So it's going to have a min on the left-hand side, a max on the right-hand side, and then the box occurs where the Q1, the Q3, and the median or the Q2 appear. Now, the one thing we want to be careful of when we're calculating our box plot is, so notice in the example we have, our Q2 is a little closer to our Q3 than it is our Q1, and our Q1 is a little closer to our min than it is on our max. So when we lay out our box plot, we want to make sure that we actually are using like a number line to plot our points, because some people get in the habit of drawing a box plot where everything is exactly symmetric. And so it could be that the data is symmetric and your box plot will look exactly like what I just drew there, but not all data is going to be symmetric. So what we want to do is make sure we're using a number line to plot our points as accurately as we can so that our box plot does reflect the data that we're given and not just some generic, oh, it always looks like this type situation. So just got to be careful of that. All right, so let's look at an example, figure out how to calculate our box plot. So for example 1, we've got following data are the number of pages in 40 books on a given bookshelf, and we want to construct a box plot. Now, unfortunately, before we can construct a box plot, we first have to figure out what the 5 number summary is. So we need to figure out what our min, our Q1, our median, our Q3, and our max is. And so what I've done for this one is I'm going to show you a little trick. So a command that we're going to use on our calculator that's going to come in handy. We're going to use it for a lot of the rest of chapter 2 as well and throughout the semester. So what we want to do is, let me click over to our calculator. And so what we're going to do is go to Stat. And so if you didn't have the list in there already, we'd have to put the list in. So fortunately for me, I didn't want to bore you by typing all 40 of these in on the camera, so I typed them in ahead of time. So here's all the 40 scores that we have. And so the command that we're going to use is, let's quit back out of this, go to Stat again. And so if you notice above, we've got the Edit button, the Calc button, and the Test button. So what we want to do is we want to go to Calc. And then we're going to use what's called the one var stats, so one variable statistics. And so at this point, it's asking me what list did I put the data into. Now, technically, if it's in list 1, you can just hit enter and it'll automatically give you the data. But if your list is in list 2 or list 3 or list 4, you have to tell it which list you're actually working with. So even though I don't have to, I'm just going to go ahead and put down list 1. So, and when I hit enter, now on the TI, you'll have to scroll down to see this. On this calculator, it puts them side by side. But all the stuff to the right-hand column is the actual 5 number summary. So notice we've got our min is our 136, our Q1 is 237, our median is 322, our Q3 is 395, and finally our max is 512. So the left-hand side, we're going to use these a little bit later, and so I'll talk about those when they come up. But for right now, just focus on those kind of bottom 5 numbers on our list. So let's go ahead and write these down, transfer them over. So I've got 136. And now I forgot what they were. That was bad. Let's see. 237, 322. 322, I think it was 395, but let me check. 395 and then 512. Now again, our max and our min were here, so we really only needed to copy off the Q1, the median, and the Q3. But there we go. So we've got our set of data all laid out. And so now what we want to do is draw a little box plot to get an idea of, does this data look like it's kind of symmetric? Does it look like it's skewed one way or the other? And so this is it's a pretty big number, so I'm going to have to use a pretty big scale in order to make this happen. So what I'm going to do is I'm going to start with probably 100 and then go by 50s, say. So let me set up my number line here. So I'm going to start with 100 over here, and then 150, 200, 250, 300, 350, 400, 450, 500, and 550. All right, perfect. Now again, since I've got like 136 and stuff like that, I'm going to be approximating these. They won't necessarily be exactly where they're supposed to be, but at least they'll be kind of in the ballpark. So when I'm doing these, like what I like to do is go ahead and like draw lines to represent my min and my max first. So above the number line, 136, I'm going to estimate is around there. And 512, I'm going to estimate is around there. And then what I do is just kind of draw a line connecting these two together. And then again, keep in mind this is my min, this is my max. And so now it's time to draw our box. So the way I draw the box is figure out where the Q1 and the Q3 lives to get the left and right hand side of our box. And then I worry about the median last. That's the last thing I actually calculate. So 237 is going to be somewhere around here. 395 is going to be almost there. So again, let's go ahead and sketch our box in. And so finally, last thing we can calculate or draw is our median. So it's going to be 322. So it's going to be somewhere around here. So we've got our Q1, our Q2, and our Q3. And so again, so make sure, the main thing is when you're laying out your box plot is, well, of course, having to find your 5-number summary, that's going to be important. But then making sure that we use the number line to accurately try to sketch what the graph actually looks like and stuff. So, all right, perfect. So let's take a look at the next example. So another thing that can come in handy with the 5-number summary is if you're trying to compare two groups that have similar sets of data. So in this case, we've got two statistics classes, one during the day, one in the evening, and we have their distribution of test scores. And what we want to do is compare the two box plots just to get an idea of how they kind of compare to each other, like where the medians live, like the spread of the data, stuff like that. So what I'm going to do is, the way I'm going to do it, I usually like to plot one above the other so I can actually just use one number line. So I can see that my lowest score overall is 25, my highest score is 99. So I'm just going to make this go from 25 up to 100, so that way just to make life easy. But you could go from 0 to 100. Let's do 0 to 100. That'll make it a little bit cleaner, even though we won't use some of it. So we've got our 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so there's our number line. And so above these, what I'm going to do is I'm going to stack both of these different box plots above the other one. So I'm going to start with the day class first. So our day class has a min of 32 and a max of 99. So that means we're going to have a min there and a max kind of there. And so I'm just going to remind us this is the day section. And so now let's calculate our Q1 and our Q3. So we've got 56 and 82.5. And then finally, our median is 74.5. So it's going to be kind of right there in the middle. So again, we've got our min, Q1, Q2, Q3, and max for this one. And so now using the same number line right above it, we want to stack our evening box plot. So with this one, so again, start with your min and max. So we've got our min is at 25, so it's going to be there. Our max is almost the same. It's just a hair inside. So now let's get our Q1 and Q3. So our Q1 occurs at 77. Our Q3 is at 89.5. And then finally our median is 82. So again, we've got our min, this is our evening section, Q1, Q2, Q3, and max. And so if we notice, looking at the numbers, like it probably didn't have that big of an impression on you, but looking at the chart, hopefully you can see what a major difference these two classes are. So notice that our, obviously the evening class has a much bigger spread because our min and our max, there's a big difference between those compared to our daytime section. But then notice that, remember between Q1 and Q2, like kind of 50% of the data lives between those two numbers. So, because this is our lower 25%, this is going to be 25%, this is 25%, and then finally this is 25%. So that Q1 and Q3, there's not a whole lot of difference in between those. There's a lot of scores that are kind of in that middle area, where here, notice how spread out this guy is. And so again, and our Q3 is really, really, really close to the max. So the idea is that we've got a lot of high scores in that later class. Now, obviously, we do have some people that did fairly badly, like we've got this minimum that's way, 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 way to the left. And so what we're going to talk about later is sometimes in sets of data, there are things called outliers, where there's a number that just doesn't really kind of fit in with the rest of the data. And so that's kind of what the problem is with this one. That person that scored the 25, like maybe they forgot there was a test, maybe they just didn't study, who knows. But it doesn't look like the rest of the data or anything like that. It seems to be that there's something a little bit off with that guy. But anyway, this is a neat way to take sets of data, kind of look at them, be able to compare them graphically, where sometimes the numbers just doesn't give us the same idea of what's going on. But all right, so to talk about those outliers I just mentioned here, so what we want to do is we want to actually figure out how to find an outlier, and then once we find it, what are we going to do to our box plot to kind of represent that outlier that's there. All right, so the first thing we need to do is we need to figure out what is our outlier. And so to figure out our outlier, the first thing we want to do is calculate what's called our interquartile range, which is a lot of times abbreviated IQR. And so what we're doing is taking our upper quartile, our Q3, minus our lower quartile, Q1, and then we're going to multiply that IQR by 1.5. So, and then from there, what we're going to do is subtract that number from our lower bound, and then see if we have any numbers in our data set that are below that number that we calculated. And then on the upper end, we're going to take our Q3 and add that number that we calculated above. And again, check and see if there's any numbers above there to see if those are our outliers. And then once we've got them, then I'll show you how we'll modify our box plot accordingly. All right, so let's first go ahead and calculate our interquartile range and then check to see if there are any outliers. So this is using the same data that we did in the last one. This is the evening section that had that weird 25 on the left. So, and I kind of hinted that it might be an outlier, but let's verify just to make sure. So to do our interquartile range, first thing we're going to do is take our IQR, which is our Q3 minus our Q1. So our Q3 is 89.5 minus our Q1, which is 77. So 89.5 minus 77 is 12.5. And so now what we want to do is we're going to multiply that by 1.5 to figure out if we have any outliers and what they are. So let's take our 12.5, multiply by 1.5, and that gives us 18.75. So again, we haven't actually found the outliers yet. We're just kind of setting up what we need to do to figure out where the outliers may or may not exist. So now that we've got this number, what we want to do is subtract it from Q1. So this is going to be kind of our lower check. So we're going to take 77 minus 18.75. And so if we do that, we get 58.25. And then now we want to do our upper check. So we're going to take our Q3, which is 89.5, and add the 18.75 to it. So 108.25. All right. So now that we've got those there, now we want to check our original set of data and try to figure out, are there any scores that are either lower than 58.25 or higher than 108.25. So now the good thing is, since our data is all smaller than 100, so there's no upper outliers. We don't even have to think about that in this case. But now we want to look and see, are there any values less than 58.25? Well, we knew our 25 was our min, so clearly there's at least one that's going to be an outlier. But if we actually scan our list, it turns out we have two that are actually less than 58.25. So this set of data actually has two outliers in it. So we've got our 25 and we've got our 45 are two outliers. All right, so how does that affect our box plot? Well, what happens is we don't want to eliminate that set of data. We want to make sure that that data is still represented, but we don't want it to be in the actual box plot itself. So what we're going to do is we're going to use dots to represent those two outliers, the 25 and the 45. And in the meantime, what we're going to do is use a new minimum based on the fact that if 25 and 45 weren't there, what would have been the next smallest number that we would use? So what we end up doing is making a new min. And so if we look through our list, it appears the smallest number that we haven't used, that's not an outlier, is going to be 65. So in this case, we're going to make a new min of 65, calculate our box plot using this new set of numbers, and then we're going to put little dots to represent our 25 and 45. All right, so let me draw our number line again real quick, just like we did before. So we got our 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And so again, I'm going to do the box plot first. So now our new minimum is 65. So it's going to go there. Our max is still 98. So draw our little line connecting them. So our Q1 is still 77. Our Q3 is still 89.5. Oops. And then finally our median is 82. So now there's our new min, same Q1, same Q2, same Q3, same max. But now again, we don't want to ignore these 2 points because unfortunately, even though they did affect what our box plot looks like, they're still part of the data. So what we want to do is go back and put a dot to represent where 45 would live and a dot for where 25 would live. So that's what a box plot would look like with outliers. So we would modify the minimum or the maximum, depending on where the outlier lives, redraw the new box plot without the outliers, but then put little dots to represent where those outliers actually occur. All right. So if you have any questions, just let me know. So again, I'd mentioned in the other video, so practice 1, practice 2, practice 3, these are all the same sets of data that we'd worked with before. So you've already technically found the 5-number summary. So now it's just a matter of drawing the box plot, trying to see if there's any outliers or anything like that. So if you have any questions or anything, just let me